Hi, my name is Julie, and this is my project, Sodium Citrate Sensitizes Multidrug-Resistant Pseudomonas aeruginosa to Triclosan. Pseudomonas aeruginosa is a gram-negative bacterium commonly implicated in nosocomial infections, such as pneumonia and urinary tract infections. However, it is resistant to nearly all antibiotics, including Triclosan. Triclosan is commonly used as an antiseptic and/or disinfectant in soaps, hygiene products, and in medical tools used in healthcare settings. Triclosan targets the enoyl acyl carrier protein reductase enzymes that catalyze the last step in the synthesis of fatty acids in lipopolysaccharides. This affects the integrity of LPS and ultimately the outer membrane of cells. P. aeruginosa has two ENRs, Fab-I and Fab-V. However, only Fab-I is targeted by Triclosan, while Fab-V is not. Possession of this Fab-V ENR is what gives P. aeruginosa its extraordinary resistance to Triclosan. The Zhang lab previously observed that sodium citrate partially eliminates resistance of P. aeruginosa to Triclosan. So the purpose of our study was to characterize this mechanism of sodium citrate-induced Triclosan sensitivity in P. aeruginosa. Although this phenotype was previously observed in the Zhang lab, the mechanism by which this occurs is not clear. LPS contains negative charges that are balanced by divalent cations, such as magnesium and calcium ions. This structure of negative charges, balanced by divalent cations, is what gives the outer membrane extreme stability in P. aeruginosa. So our hypothesis was that sodium citrate's negative charges chelate or steal divalent cations away from LPS, weakening its integrity and sensitizing P. aeruginosa to Triclosan. The salt wash method was previously performed by researchers at the Zhang lab. We used the P. aeruginosa MPA01 strain, which was grown overnight in lysogeny broth. The overnight culture was then centrifuged and the LB liquid portion was removed and discarded. The remaining cell pellet was then resuspended or washed in various salt wash solutions to a final optical density of 1 at 600 nanometers. Tenfold serial dilutions were then performed in their respective wash solutions, and all dilutions were spotted onto LB and LB Triclosan plates. Plates were then incubated overnight. The results of wash experiments were quantified by colony-forming units per milliliter, or CFU per mil, the next day. One-way ANOVA with multiple comparisons tests were used to compare the log 10 CFU per mil of phosphate-buffered saline, our negative control, with each type of wash solution on Triclosan and LB plates, and all salt wash experiments were repeated 3 times. Sodium succinate, sodium acetate, and sodium phosphate all have similar chemical structures to sodium citrate, so we predicted that they would have a similar chelating effect. However, only citrate, succinate, and phosphate reduced survival of cells on Triclosan, while acetate did not. Sodium citrate, succinate, acetate, and phosphate have 3, 2, 1, and 3 negative charges respectively, so it's possible that the single negative charge on acetate is not enough to chelate cations away. When MPA01 was washed in a mixture of sodium citrate and magnesium chloride, or sodium citrate and calcium chloride, MPA01 regained its resistance to Triclosan as if sodium citrate was not added at all. Addition of magnesium chloride also protected MPA01 from sodium phosphate and sodium succinate. EDTA, which chelates divalent cations and disrupts gram-negative outer membrane, was also tested. As expected, EDTA significantly reduced survival of MPA01 when subsequently exposed to Triclosan. This phenotype was also reversed by the addition of magnesium chloride, suggesting that sodium citrate may operate in a similar mechanism as EDTA by chelating divalent cations away from LPS. Magnesium chloride also protected cells from polymyxin B, an antibiotic that mainly targets gram-negative bacteria by binding to and subsequently increasing permeability of the outer membrane. So results support our original hypothesis that sodium citrate exerts its effect by chelating divalent cations away from LPS. Moreover, addition of magnesium chloride protects the cells, so we predict that sodium citrate binds to free magnesium ions in the magnesium chloride solution instead of to magnesium ions in LPS, thus providing a protective effect. Future steps that can be taken is to test the effects of Fab-V overexpression or the effects of a Fab-V or Fab-I knockout on sodium citrate-induced Triclosan sensitivity. Furthermore, we can test whether this phenotype is generally applicable to clinical isolates of P. aeruginosa. And I'll leave you here with some final thoughts. Huge thank you to Dr. Tao Zhang, all Zhang Lab members, and Pierre for making this such a rewarding experience.